Hi, my name is Brad Cunningham. Today I'm going to walk through setting up the TODO application that we built in a previous video for Windows Phone, and we're going to set that up to cross-compile onto Android. So we're going to try to share as much code as possible from our Windows Phone implementation and get a comparable app running on Android with that shared code. So the first thing you need to do, if you don't already have the code down, it'd be a good idea to go to the GitHub repo where we're hosting this code so you can get a reference to this. We have on GitHub, the repository is called tig-cross-platform mobile. There's a couple branches in here for you to look through. The master branch has all of the completed code with Android and Windows Phone fully working and completed. So if you want to start with a completed version just to make sure it works and see where you're at, you can do that. If you look on the Windows Phone Lab 1 branch, you'll get the Windows Phone code with to-do implementations, and on the Android branch you will get the to-do versions as well with the code commented out for the Android implementation. Okay, so once you pull the code down, I pulled down master here just so I can show you the fully completed app. Then I'm going to open Xamarin Studio and I'm going to go open my project. So I'll just go file, open, and go find my project on disk. And you're going to open the tig.todo solution file. And from there you'll see there's 3 folders: Android, Common, and Windows Phone 8. All of our common code is going to be what we share, and then Android and Windows Phone 8 will be the platform-specific code, and that's all grouped under the same SLN file. And what you may notice here is that you may get a warning pop-up. It says the Windows Phone 8 tools version doesn't match, and it couldn't load the Windows Phone project. That's to be expected because in Xamarin Studio it supports Android and iOS development, but doesn't support Windows Phone development. So our Windows Phone project will give us an error saying the load failed, but that's fine because all we're doing in Xamarin here is to work on the Android project. So we can just go ahead and say OK to this error, and you'll see that the Android project and the Common project load correctly. And I can expand these, and I can go in and look at our main activity in Android. And if you followed along with a previous video on getting started with Android, this structure should look familiar to you. You have a main activity entry point, and from that entry point, we're setting our content view, and we're doing some other code to wire up our task code. So the first thing we want to do is we want to see if we can compile this and run it just as is. We've got the master branch from GitHub pulled down. We've got the fully completed code, and we just want to build and see what happens. So I'll go up to the build menu and just say build all. I want to build this whole project. And as this is building, the first thing you're going to notice, you may get a build error. In my case, I do, and I wanted to show you this error in case this is something you come across. When you get an error in Xamarin Studio, remember that all the messages are up top here, and you can click on this error dialog. And what you'll find is this: my error is saying could not find Android jar API level 18. It says this means the Android SDK platform for API 18 is not installed. So if you follow along our previous video when we were setting up our Android development environment, we should be somewhat familiar with this error message. To figure out what's going on, we can go to our Android project, right click, and go to options. From the options panel, we go to build general, and under there we can see what target framework this application is targeting. For our to-do application, we're targeting Android 4.3, which is Jelly Bean. So when we target Jelly Bean, that means that we have to have the corresponding Jelly Bean SDK installed. So we'll go ahead and say OK. We'll go back and look at our error, and it says API level 18 is the SDK that this project is targeting, but we don't have it installed. And it's telling us what to do. Go to Tools, Options. Again, if you followed in a previous video, you remember this dialog. We're going to go into Xamarin Studio. We're going to say Tools, Options, and open the Android SDK Manager. And when the SDK Manager loads, it's going to show us all these versions of the Android SDK that we can install. We can kind of collapse all these. We can see a few. Now, if we remember back to our error message, it was saying API level 18, which is Android 4.3. That's Jelly Bean. That's the piece that we're trying to install. So I'm going to install just the SDK platform. Yeah, I'll go ahead and install actually the ARM and Intel system images too. That will give me the ability to launch an emulator for Jelly Bean without having to do much configuration. And why not? We'll install the Google APIs, I suppose. We don't really need the sources for the SDK. We're not going to be compiling from source, and in our case, we don't care about the samples. So just make sure at the very least you have SDK platform installed for API level 18, and then go ahead and say install for packages. Again, it'll take you to this dialog here. You need to accept the license. This is an instance where there's 2 separate licenses. Just click on the top level items, click accept, and then click install, and that's going to start a download here. and this window is downloading API level 18. This is going to take a few minutes, so we'll wait, and when that is done, we'll come back. Okay, so we're back, and everything's been downloaded now. You can see it says done loading packages, and if we look for API level 18, which is 4.3 Jelly Bean, the SDK platform is marked as installed. So we'll go ahead and close that, and we'll go back here and we'll just try to build again, and let's see if that gets rid of our error. So you can see it's building our Android project, and once that compiles, we'll see that there is no longer an error about the target framework mismatch, because the version of the framework that, and there you see it says build successful, the version of the framework that we are targeting is now installed on my machine, and we're able to run and deploy our application using API level 18 Jelly Bean. So the next thing we need to do is we need to get an emulator running for our 4.3 Jelly Bean OS. So again, if you remember from the previous video, we go to Tools, we can open the Android Emulator Manager. And from the Emulator Manager, we can see some options here for various mono Android emulators. And now we don't see one here with a target of 4.3. We have 4.0, 4.03, 4.42, and in fact that was one I was working on. I'm going to go ahead and delete that. And we'll say okay. So it looks like we don't have an emulator that's running Jelly Bean. So it'd be nice if we had one running Jelly Bean. So what we can do is actually create a new emulator. From inside the AVD, we'll say new, and we're going to call this Jelly Bean. And the device, this device drop down here shows us some various spec devices, the Google Nexus devices for various screen sizes and screen resolutions. There's also some generic profiles down below here for different screen sizes and resolutions. I tend to like to stick with the kind of spec devices if I can. And for this one, I think a Nexus 4 or the Galaxy Nexus is probably fine. So we'll just go with the Galaxy Nexus. And now we get to pick what version of Android we want to run on this phone. And you can see this drop down here. It lets us select from all the different API SDKs that we have installed. Right? So we have the Android 4.3 API level 18. That's Jelly Bean. That's the one that our TODO application is targeting. So I want to set up an emulator that's running that same version. We can decide whether it's an ARM or an Intel Atom chipset. I'll just go with ARM. That's going to be fairly common in mobile devices that they run ARM chipsets. There's other settings on here that you can tweak with. The only other one I do is I kind of turn the RAM down for what we're doing. We don't need as much RAM. So I'll just turn it down to something lower. The Android virtual device, the AVD, is a virtual machine, and it will use your system resources to allocate some of that RAM. So it will slow down your host machine. So if you don't need all of the RAM, turning it down is probably a good idea. There's some options with cameras and hardware keyboards and that sort of thing. I usually just leave those alone, but I will size down the RAM. And then we'll go ahead and say okay to start this AVD. Now it'll give us this dialog telling us just a confirmation of everything we've set. That's pretty typical of Android related stuff. It's pretty programmer focused. These dialogs are not generally that friendly. It's a little not that clear as to what they're telling you here, other than they're just showing you a dump of all the properties that you set. And so we'll go ahead and say okay. And once we do that, now we have an emulator listed here, an AVD listed called Jelly Bean with a target of Android 4.3, an API level of 18. And that 4.3 platform with API level 18, that matches what our TODO application is targeting. So we'll go over here and just click start on the emulator. It'll give us a launch option screen to tell us what size, and if you want to wipe user data. I usually just leave this alone and just click launch. Then this process here is going to start the Jelly Bean emulator, and what pops up is our emulator UI. If you looked at a previous video, you notice that this screen looks a bit different. It's quite a bit bigger. It's a newer version of the API. It's a newer version of the resolution, so it's formatted differently than what we're used to. And I'm going to let this boot up. This process does take quite a long time, as we mentioned earlier. This can take upwards of 20 minutes. So once this is booted up, we'll come back and we'll deploy our application to it. Okay, so now we're up and running. Our emulator is booted up. We've got a Jelly Bean emulator running. We're landed on the home screen of our emulator. We can see it's our emulator that we call Jelly Bean. And this is running the same target version of the Android SDK that our app is running. So I'm going to click back to the AVD manager and close that, and click back to Xamarin. Okay, so now we're back in Xamarin Studio, and what I want to do is run my application. I can click on my Android app, I can right click on it and go ahead and say run item. And what that's going to do is it's going to build our project, and then what it'll pop up is a selection window that allows us to pick the emulator that we would like to run our app on. And it shows in black here that we've got one running called Jelly Bean. We'll go ahead and say OK. And what this starts is the deploy to device step, and it's detecting our installed packages to see if we've already installed this application on there, and whether the shared runtimes for Mono for Android are installed or not, and whether the Java runtimes that are needed are installed on this emulator. So this is going to take quite a long time, 10 minutes, 10 to 15 minutes to do. So we'll come back when this is done. Just keep an eye on your status window up here as your build runs. And make sure that it's moving forward and it's installing packages. Okay, so my app is done building and deploying to the phone, and now it's running. I had a message up here that said deployment complete, and if I flip back to my emulator, you may see your emulator go dim. That's a Android setting. You just click in the screen and it'll wake it back up. It's like when your phone is dimming out. But I click back in the emulator, and now what I see is my To-Do app is running. It says TIG To-Do Android. And we're on screen with our app, and I've got a little text box here, and I can type in, and I can say hello world, and I'm using my physical keyboard to type into this box here. And then I can go ahead and click on the add button and add my task, and I can say hello world again and add a second task and add a third task here, and you can see that we have a built up list of tasks, and I can click on them. So our app is running. Our code is running in Android, and we're in pretty good shape. So now what I'm going to do is go back to Xamarin Studio and click Stop. And when I click Stop and flip back to my emulator, you'll see that the app quits, and we go back to the home screen on our emulator. We want to leave this emulator running so that any changes we make to code, we can quickly redeploy to the emulator. We don't have to wait for it to start up again. We don't have to wait for the shared runtimes to be installed. So now that our app is up and running in our emulator, let's take a look at the code and figure out how we were able to share some of this code. So the first thing to look at is our Solution Explorer here on the left, and we want to see our project structure. So we have a solution called TIG To Do, and we have a project called TIG To Do Android, and then one called TIG To Do Common, and then our Windows Phone project, which we talked about earlier, has failed to load because Xamarin does not support Windows Phone. It just supports iOS and Android. So the first project we want to look at is TIG To Do Common. And if we right click on our project and we say options, we want to see what kind of project is this. Is it a C# class library? Is it a portable class library? You know, what is it that we have built here? So if we go to build general, what we'll see is this screen here, and this is the portable class library screen. So this project was created by creating what's called a portable class library in Xamarin. The portable class libraries are a subset of the .NET framework that is implemented across all of these platforms in a common way. So it gives us a way to write a single set of C# code that can be targeted to all of these target frameworks that we've checked and deployed on those devices, and we can be guaranteed that it will run on all of those devices. So we've just taken the default checks. The key here is that we've targeted Android and iOS along with Windows Phone 8. And by doing that, we know that any code that we write, if it compiles, it will be runnable on those devices. And so let me show you how we did that. So we went to our solution, we right-clicked on it, and we said Add New Project. And when we said Add New Project, we're given the Xamarin dialog. We go into this dialog here, and what we want to create is a C# library. So not an Android library. We don't want Android specific. We want to click on C#, and when you click on C#, you'll see that there's an option at the bottom for a portable library, and it says this creates a C# library that can be used in Windows Silverlight, Windows Phone, Mono Touch, and Mono for Android. Mono Touch is the name they give to the iOS version, and Mono for Android obviously is what we're working in. So what we want to do is create a project that is portable across all those frameworks. So we went ahead and did that. We called it TIG To Do Common, and that's what came up here with our project. And then inside TIG To Do Common, we moved over the code that we had in our Windows Phone application. So you may remember we had the bindable class, and this was just implementing iNotify property change. You notice we had to comment out a few pieces here, and this is called out in the lab. We commented out a few pieces that are not available in the portable class library, and that's mainly that this annotations framework we were using was not available on the portable library to target Android and iOS. So we had to reduce our code a bit so that it worked. And we'll go over here. You remember the TIG to do item. This is the same class that we had before. It inherits from bindable. The only changes we did here is we added the name of the property to the onProperty change method. And we had to do that because the caller member name feature was not available to us with the set of runtimes that we've targeted. So this code is identical to what we did in Windows Phone, and we've actually gone back into Windows Phone. You'll see on the, if you pulled the code off master, we've gone back into Windows Phone and cleaned up the reference. So Windows Phone is referencing this exact same compiled library. We did some refactoring to what used to be the to-do view model. We call it now the task manager, and we did a little bit of refactoring here because the concept of commands was not available in the portable class library. So the hooking up in Windows Phone that we did through binding to a delegate command, that code now all lives in Windows Phone 8 specific, but we wanted to pull some common code out to a class that can be shared. So we pushed down this code for Task Manager that is shareable across both platforms, and that's really just the logic to maintain a collection, an observable collection of to-do items, to have the concept of a new to-do item, and then to give you the ability to add and remove those to-do items. So this code, again, is shared between both platforms, and we've had to simplify it to go to the lowest common denominator here. We need to have code that will run on both platforms. So that's the makeup of our common library. We went into our solution, we created a new portable class library, and then we pulled code over from what used to be in the common project. We pulled it into this new portable library, made a few changes so that it would compile, and then we went into our Android project, and we went to the references for the Android project, and we right-clicked on it, and we said Edit References. And from here, we're able to select what references that we want to add to our project, and in this case, we added a project reference to TIG to do common. Now, I'm in the full version of Xamarin Studio here. If you're in the free version, it may look a little different, but you should be able to right-click on the references and get to this dialog and add a reference. So now our Android project is referring to TIG to do common, which is our portable class library. So now we're going to go back into the Android world, and if you followed along in the previous video, you'll remember this structure. We start with main activity, and that's our main entry point into our Android application. In there, we have an onCreate method, and we're setting the content view to resource layout main. So we look back in our Solution Explorer, we go to resources, go to layout, we go to main AXML. Remember, this is analogous to the XAML file. This is just our UI, and our designer here is loading, and what we really care about is the code behind here. So I'll just flip to source, and you can see it's a linear layout, and we've slightly changed the UI from what was in the Getting Started application. We've got an edit text, basically just a text box that you can type into, and we've ID'd that as to do item text, and then we've added two buttons. We've added a button here for adding, and we've added a list view to show all of the items, and we've given them all names. So we have the button's ID is add, the list's ID is list tasks, and the text ID here is to do item text. So we have three items in our main AXML, and if we flip back to content, our designer is running. So you can see here's the add button, and then here's the edit text box, and then this is the list control down below. So now if we go back to main activity CS, we want to see how we're getting out those fields from the view. And the first thing you notice is that we create a new task manager. And if we right click on this task manager and say go to declaration, notice where we go in Solution Explorer. We're into the common project, right? So this is the shared class that's running in that portable class library that Windows Phone and Android are both using. So again, in Android code, we're able to create an instance of a task manager, and then we go ahead and find the button and the list view. So we're finding the add button and the list tasks. We're going to hook a click handler up to the delegate. We're going to hook a delegate up to the click handler of the button So when you go to add a new task, we're going to go find the text box. We're going to get the text box text property, and we're going to set the task manager's new to-do item text to what you typed in. So we're able to take this data and shove it into the task manager object. Now you'll notice one thing that's different here between Android and WPF is that we're not doing data binding. There isn't data binding out of the box with Android. So a lot of what you end up doing is some wiring up of code behind. Maybe not as nice as what you can do in Windows Phone, but this is the basic approach to doing it in Android. There are some third-party libraries out there and frameworks to do some data binding, but we want to stick with what comes out of the box to start here. So we are taking the text you typed in and wiring it up to the task manager, and then we're calling a method on the task manager called add to do item. And again, go to declaration, or you can press F12. Press F12, and we go to that method, and that method is in our shared task manager class, and that's going to add the new to-do item to our list of to-do items, and then reset our to-do item to an empty one. So now if I go back, we'll say add to-do item. So once we do that, then it's adding our new to-do item to our list. So the next thing we want to look at is how we're getting the list of tasks. And if we go and we look at, when we click the add, main what we're doing is we're just working with the task manager here, and we're setting its text, and we're calling add to do item. Now we need that to trigger an update to the UI to put those items into the list. So the thing to notice here is we're leveraging a class in the Android API called base adapter, and we've created our own derived type of that called task list adapter. We'll show this in just a sec. And what we do with a task list adapter is we send it a reference to this containing activity, this main activity, which is the parent window, and then we send it a reference to the collection of items that we want the adapter to work with. And then we take the task list view, which we found here, and we wire up its adapter property equal to this task list adapter that we just created. So we found the UI element that is the list view, and we need to set its adapter. So you can think of this kind of like data binding. This is a little bit of plumbing that the Android framework provides that allows you to take a collection of items and provide them to a list and have the list kind of manage that for us. So task list adapter, if we press F12 to go to definition, this is a class that we implemented, and notice that this is Android specific. So all of this code here only runs on Android, and it's inheriting from an Android class called base adapter, and there's some generics here. So it's a base adapter of T, and so we say it's to-do items. So the adapter is going to work with to-do items. We have a couple things stored internally. We have the context, which is the main activity window. That's what happens when we construct it. We pass in the context. And then we have the collection of tasks that we want to work with. And notice what we're doing here. We're wiring up to an event handler. So the collection changed event on the list of tasks, we want to hook into that and do something. So if we flip back to this task manager add to-do items, notice that the collection we pass in are the to-do items that are owned by the task manager. And if we go into the task manager add to-do items, notice that we're modifying the collection. We're changing it here and adding a new item. So when we add that new item, it's adding it to task manager to-do items. And if we go back to our adapter, that's going to trigger the collection changed event in the list of tasks. So now inside our Android specific class called task list adapter, we can listen for an event that happens when a new item gets added to the collection. And so what we do here is just kind of an inline delegate, and we tell it to tell the tell the task list adapter that your data set has changed. You need to refresh yourself. And if we scroll down and look at what this class is really doing, we give some overrides for positionals and get item by ID and account method, just overriding so the adapter can count the items internally. The other main thing we do is get the view. So we want to provide what the UI is. I kind of think about this like an item template. What is the UI structure for the items that we show in the list? So the first thing we need to do is we need to get the item. So for each item in the list, this task list adapter is going to call the get view method and tell us which position in the list it wants. And so we go and extract that to do item. and then we go and figure out the view that we want to use. In this case, we're using a baked-in control from the Android framework called the simple list item checked. And so that's just a list item with a little check mark next to it. And then we create one of those as the view. We try to figure out if we have one, if we already have one. If we don't, we go and create one, and we have that as the view. And then on the view, we need to set the two properties. So a checked text view has two properties. It has its text and whether it's checked or not. And this is where we kind of wire up our bindings. So we want the current item we're on, which is this guy up here, which is our to-do item. We want to look at its text property and say that that's the text of the item that I want you to put in the list. And whether or not this item is checked is based on the is completed. And then we'll return that view. And so the term view here can be a little overloaded, but what they're giving back is the individual template for each of the items. So let's run this again so we can kind of look at this visually and understand what's going on. And that's the extent of our to-do app. It is quite simple. So we're gonna press play, and if you don't have the play button here, if you've just got a hammer, like a little build icon, make sure that your startup project is set to the Android project. So go into your Solution Explorer, right click, tell it to set as startup project for the Android project, and then you should get the option to just play. And this thing should find our emulator, and it does. And so I'm gonna type in hello world, and I'm going to add. And now when we add, notify collection change has fired, and we're creating a view. And what you can't see over here is actually there's a little check mark. If I click on it, you can see to the right there is a check mark. And that's the UI piece that we looked at here in the adapt. So now I've got two items in my list, and they both have their check marks next to them. So let's make one change, and let's see if we can get these check marks to always be checked. So there's a couple ways we can do this. One way is we may want to come in here and say, instead of is completed, let's just always set the check property to true. And when we do that, now we'll go ahead and build our application, make sure everything builds, still good. Let's see, we've still got our running app here, and let's go and let's press play here. Okay, so our deployment completed, and it started our app again, and let's see what we've managed to do. It's still booting up here, so give it just a second. And if we look at our output windows, you should be able to see it up here with views and pads, kind of a weird term here, and then application output. And then we can see what's going on. So now if we flip back to our emulator, and it thinks that our Android app is not responding, it should be fine. And we can say hello world, and let's see if we add this. And now you can see that there's a check mark set, and that check mark is turned on. And if we add another one, the check mark will be enabled as well. So now we get an idea that we know that this bit of code is generating the individual items that show up in our UI. And I'm going to go ahead and stop running. And we'll set this back to is completed. Item.is completed. And now, since we know that this item is a to-do item, another way we could test this to figure out how it all hooks together is we could go into our task manager, and for every to-do item that we create, let's go into to-do item. Instead of is completed, let's just always return true and say that everything is completed. So now we can see if the data is being passed through as we expect. We'll just kind of move this out here. Notice syntactically this is all just C#, so we should be familiar with how this all works. And now I'm going to go ahead and build. So now the shared class in tig.todo.common is to-do item. That class is portable. It's compiling to run on both Android and Windows Phone. I've made a change in that class, recompiled, pressed build, and what's happening now is that Xamarin is deploying the app onto my phone, or onto my virtual device here, and we can come in and kind of watch the application output. It takes a little while to get the whole new version up and running inside of the emulator, so we'll wait just a second. And now we can see that there's an add button, and we'll go ahead and say hello world one more time. I always seem to do a capital O there. There we go. We say add, and now you can see this is checked. And now notice that if I come in here to my task list adapter and I put a breakpoint and I add another one, I click add, and now you can see this will take a second the first time to hook up. Now my breakpoint gets hit inside the get view, and it's saying the checked property here is set to false, and it wants to set it to whatever the items is completed is set to. And so if we hover over is completed, and we'll say it's true, and if we hover over item, you'll see that it's a TIG to do item. And this dialog here for debugging should be familiar to you if you've worked in Visual Studio. We can see the text is hello world and is completed is set to true. We'll go ahead and take our breakpoint off and go ahead and keep running and come back to our AVD, and we can see that there's 2 check marks. Okay, so that is an overview of the TIG to do item application and the shared code that is now cross-compiling onto Android.